This is solving equations using logarithms, and this is exercise 3E in the C2 textbook. So we start off with a nice simple question, 3 to the power x equals 20. Okay, now the easiest way to solve this is to use the work from exercise 3b and rewrite that as a log statement. So we'd have x equals log to the base of 3 of 20, and that would give our answer. So we've got that nice cool button on the calculator, the one in the top right corner, that one there. We can just press that, fill in the 3 and the 20, and away we go. We've got the answer. But I want to use a different method, which we call taking logs of the both sides. Okay, so it's that concept of solving an equation where we just do the same thing to the both sides of the equal sign to solve an equation. Now a log is a function, so as long as we take the log of the same base to the both sides, then we can use it to solve an equation. Now I'm going to use this button here, that log button. Remember, that's shorthand for the log of base 10, and all calculators have that button. Well, all scientific calculators anyway. So 3 to the power x equals 20. We start there. So I'm just going to apply that log to the base 10 of 3 to the power x equals log to the base 10 of 20. Now I don't put the 10 in there because it's a common logarithm. We use the power rule to bring that x out, as I just showed you there. So x comes out in front, so we've got x of log 3 equals log of 20. Okay, so we just shrink them up and move them up a little bit. Okay, and then we can just divide by both sides by log of 3. So x is going to be log of 20 divided by log of 3. So whether you've got that new fancy calculator with that fancy button, or whether you've got, which is the calculator you should have, or if you've got an older scientific calculator, you'll be able to solve those equations now. So if you do that in your calculator, you get 2.73 to correct the 3 significant figures. Now just imagine solving that equation without the knowledge of logarithms. It'd be an absolute nightmare. Okay? So there we go. On to the next example. Right, so now we'll do a harder question. Okay? Now with this one, we are going to have to use that method of taking logs of the both sides. We can't rewrite that out as a statement and just use our calculator. Okay? So I'm going to take log to the base 10 of both sides. So that gives me log 7 to the power x plus 1 equals log 3x plus 2. Okay? So let's move that there. So this is going to allow us now to use that indice rule where I can bring the x plus 1 and down in front of the log, and x plus 2 down in front of the log. Okay, so rewriting that out, I'll have x plus 1 times log 7 equals x plus 2 log 3. Okay, remember that log 7 and log 3 are just numbers. Okay, just long decimal numbers, so I can still expand those brackets the same way as I would as if it was a 7 and a 3. Okay, so I'll multiply the x by log of the 7, multiply the 1 by log 7, and I do the same on the other side. So that's going to give me x log 7 plus 1, also log 7, so that's log 7, equals x log 3 plus 2 log 3. Okay, so what we're going to do now is we're just going to group the x's on the one side, so the x log 7 and the x log 3, we'll take the left hand side. That log 7 we take to the other side, so we've got everything involving x on the one side. I could take that 2 into the 3 if I wanted to, and make that log of 9, but there's no need. You can just let our calculator do all the work for us. Okay, so let's just shrink that, so give us a bit more room. So our next line is going to be x log 7 take away x log 3 equals 2 log 3 minus log 7. Okay, now to get that x on its own, just imagine what you would do if you were those were the numbers. And we're going to factorize it. So you're an x common in the both, so we take x out of the bracket, we'll have log 7 subtract log 3, and that's going to be equal to 2 log 3 take away log 7. Okay, again, still looks really complicated, but we're going to let our calculator do all the work for us at the end. So x is going to be, so I'm going to divide both sides by log 7 minus log 3. Okay, so that give me 2 log 3 minus log 7 all over log 7 minus log 3. Okay, I've missed off the 3 there. Yeah, let's just take it back in. There we go. No one's going to notice. So, plug all that into your calculator and you're going to get 0.2966 to 4 decimal places. And you run around that then to 3 significant figures. Okay, so we're going to finish off with a much harder question. And these are equations of the type that in the last set of questions in the exercise. Okay, so they're ones like this one here. 5 to the power 2x plus 7 lots of 5 to the power x minus 30 equals 0. So have a little look at that for a second and try to think, does that look similar to a type of equation that you've solved before? Okay, you might spot it, you might not. Okay, so if we use some C1 magic to change that equation to see if we can spot the method that we could use. So I'm going to use that power rule. So the one where I've got x to the power 5 raised to the power 3, for example, that gives us x to the power 15. Yeah, that's the one where we just multiply those powers together. Now in the equation, that 5 to the power 2x, well that is 5 to the power 2 times x. So we could rewrite that. If I had 5 to the power x squared, that is 5 to the power x times 2, or 5 to the power 2x. So we could manipulate that equation slightly. So if I use that to change my equation, perhaps you would then spot what we could possibly use to solve this. Okay, so I'm just going to use that then to change that. So I'll have, all my terms will be in terms of 5 to the power x. So that's going to be 5 to the power x all squared plus 7 5 to the power x minus 30 equals 0. So I'll have another look for a few seconds. Can you spot what type of equation we could use to solve that? Something squared plus 7 lots of something minus a number equals 0. What type of equation from C1 and IGCSE have you done that looks similar to that? If we let y equal 5 to the power x, because 5 to the power x is the awkward bit, and we change it again, you might definitely spot it. Okay, so imagine those 5 to the power x's in that line above. I'm going to change to y's. So I'd have y squared plus 7y minus 30 equals 0. So we've changed it into a quadratic, because quadratics now are really easy to solve for us. So we're looking for a number, multiplies together to give us minus 30, adds together to give us 7. So our answer is going to be y plus 10, brackets y, subtract 3. Okay, that's going to give us y equals negative 10 and y equals 3. Okay, now be careful, the question's not finished yet because we've changed our equation into a quadratic equation by using substitution. So those y's are actually representing 5 to the power x. So what I've actually solved is 5 to the power x is equal to negative 10, and 5 to the power x is equal to 3. So we need to solve for x, obviously, because we're solving our original equation. Okay, now if we look at the first one, just think, is there a number I could raise positive 5 to get to negative 10? Well, if I raise it to a fraction, I'd have a root of 10. If I raise it to a negative number, I'd just get a fraction, 1 over 5 to the power of something. Obviously, if I raise it to a whole number, I would get a positive answer. So there's no number, so there's no solution to that equation. There's no number I could raise, power I could raise 5 to get to a negative number. Okay, so how easy is that? So one done straight away. Okay. And then to solve the next one, you could use that button in your calculator. You could rewrite that as x equals log to the base 5 of 3. But I'm going to do the taking logs of both sides method just to reinforce that. Okay, because it's such an important method. So we get log to the base. So x log 5 equals log 3. Take the log 5 to the side. So I'm going to get x equals, where is it? Come on. X equals log of 3 divided by log of 5. I'll stick that into my calculator. Okay. There's it, nice and neat. So x is just going to be equal to 0.6826 dot 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 dot. You can round that then to 3 different figures. Okay, let's just put it over there. Alright, again, imagine solving that type of equation without the topic of logarithms. Okay, right, off you go, good luck.